स्टार्ट हो गया स्टार्ट की हो रहा है ओके hello guys, hello everyone, this is Ashank David and in today's live session we are going to talk about a DSA concept and for those people who are joining new, let me just tell you about our live sessions. Every Saturday in Coders Arcade we do go live into our channel and we probably do something related to placements or something related to technical field in terms of IT. So let us start this, and from today onwards I am going to start with DSA placement series. So stay tuned for all those things in the terms of technical live and videos. Subscribe to our channel Coders Arcade and don't forget to press the bell icon so that you won't miss any future updates. This is Ashank David. Let us start with our DSA concept, and in today's live session I am just gonna go live because this is just the first live session of DSA placement series. I am going to start with the STL vectors, which is very important for all of us to learn in before we go ahead into DSA, because there are many different concepts in DSA, data structures and algorithms, which are required to use vectors in this case. For example, we can use graphs. In graphs we use vectors to solve problems related to adjacency list and adjacency matrix. We talk about graphs in different forms. We can create vectors, like when you will be doing BFS, DFS, in that time we usually create vectors for different things. So there are a lot of different concepts, like in terms of implementing any stack or a queue, we can use a vector in that case in order to understand how this works. Today in today's live session, let me start with vectors here, and let us start. First of all, we need to understand what exactly is data structures and algorithms, because this is just the starting of this series. I would like to first introduce you towards DSA. So let us start without getting any delay in further, right? So I am going to open up a notes, and I'm going to explain you how this works, and then we will start with the programs. Okay. I guess so. I'm audible, right? Am I audible? I'm audible, hopefully, yes. Let us start. Let me just also open up my live session here also, so that I can see the comments also which are coming. Right. Okay. Well, let us start, guys. So we are here to understand about DSA, and this is our first live session on DSA placement series. So for those people who do not know about what we are going to do, what are we doing here is we are going to learn about DSA, all the concepts from DSA. We are going to go into depth of everything, and we start solving problems into DSA in LeetCode and other coding platforms, and we will understand how to solve so many DSA problems. At the end of this live sessions, when we will progress into more and more live sessions, we will understand how we can solve problems. Let us start. First of all, in today's class, I want to introduce you towards DSA. What is DSA? DSA stands for data structures and algorithms. If you want to get a job, in India or in any other country, in IT field especially, you need to understand about DSA. DSA is the only subject which will actually get you a job if you are talking about placements. DSA is all about understanding about how the data structures work. What is data structures? In a moment I'll just cover that. What are algorithms? I'm going to also cover that as well. Understanding how the things work and how to solve a problem after implementing the structure. In this, we are going to use a programming language to implement all our stuff. Mainly we are going to, as in the thumbnail you might have seen that we are going to use C++ in this case to solve problems and understand about more and more data structures in this case. If you are able to solve a DSA problem, then it is going to be very easy to get a job in any IT field. So let us start. What is DSA? DSA stands for data structure. Okay, data structure and algorithms. What is exactly is this data structure? Data structure. To understand this properly, we need to understand about a real life example. Let us take a real life example. Let us say I am giving you two scenarios here to create. Let us say in the first scenario, you woke up in the morning and you want to get ready, and I said get ready, you want to go somewhere. I said that you have to get ready now. I'll give you a big random pile of clothes and I ask you now that you have to get ready. Tell me how much time it will take for you to get ready from that unorganized collection of random clothes. It will take a lot of time, right? Because in that case you will search for your favorite item from that big pile of random collection. That will waste a lot of time and it will result in going into very less efficiency, dropping the efficiency of the way that you approach in that problem. That is because you are having an unorganized collection. Let's take another scenario and understand this. You woke up in the morning and I said that you have to get ready, but in this time, rather than giving you a big pile of random clothes, I give you a wardrobe full of your clothes. Now tell me how much time it will take for you to get ready from that wardrobe. Takes very less time, because now you know, as soon as you open the wardrobe, you know where your things are kept. I know where my shoes are kept, I know where my shirt is kept, I know where my dress is kept, I know where my sandals is kept. I know everything where all my things are kept. Why I know? Because it is an organized collection. Here you will take very less time in order to get ready, because in real life that wardrobe is a data structure. This is that data structure. Data structure, we learn about organizing our data. Organizing our data. Once you understand how to organize our data, you start learning about different algorithms which are applied onto these data structures. What are algorithms? The way or the operation that we perform on these data structures in order to solve a problem. For example, in your real life, that wardrobe can be your data structure, but the way you access the data inside it can be an algorithm. It depends upon what do you want to do on that particular wardrobe. It depends, you want to search a particular item or you want to sort the wardrobe in a particular fashion. So that is what you're gonna do in algorithms. So in this case, one comment came, Manushri Shetty, sir, will this videos of live series will be uploaded into your YouTube channel? Yes, these videos will be uploaded in the YouTube channel. Once the live gets finished, we will just post it in the YouTube channel so that you guys can later on also see. Let's continue. So yeah, so basically I was telling you about data structures and algorithms. So basically data structures are the places or the structures where you store your data so that you can efficiently work on it, and algorithms are the operations or the programs that works on these data structures in order to perform some particular operation. For example, as I told you, you want to search a particular item, there are different ways of searching items. Maybe you are doing a linear search, or maybe you are doing a binary search. In computer science and data structures, we learn about these things of how different ways of searching are there in a particular collection of data. In this, we are not dealing with clothes, but we are dealing with a particular type of data. Generally, it can be an integer, it can be a character, it can be a string, or it can be any type of specific data. And algorithms are, so basically those are the algorithms. Maybe you want to sort a particular collection. In that case, you have different algorithms like bubble sort, selection sort, merge sort, heap sort, and so on. You might have heard about these sorting and selection, searching algorithms. When we will study about more and more advanced data structures like graphs, we will be talking about the algorithms which are very popular into that. For example, we are going to talk about Dijkstra's algorithm. People call it as Dijkstra's algorithm. or Prim's algorithm, or maybe Kruskal's algorithm, maybe topological sorting algorithms, maybe Khan's algorithm, cycle detection algorithm. All of these different types of algorithms we are going to talk about once we reach that data structure. Well, because this is a first live session, I am not directly going to go into the data structures and pick one first data structure. Let us understand about this and let us prepare for the main data structure that is going to come next. So let us continue. I hope so that in this you have understood that what exactly is data structure and what is the algorithms, why we are learning this. In different placement companies, when you go for a particular placement in a particular company, the questions are asked related to this. How would you solve this problem when this is the scenario using a particular data structure? In that case, you have to solve that particular question using that operation or understanding of that particular data structure. This is what you are going to expect or expected generally. Okay. So let us continue and understand. So first of all, I have told you about what is data structures and what are algorithms. We have understood this very well. The next thing that we are going to talk about in data structures is your collections, basically. What are these? Let me just talk about that first. Let us talk about that. Say for example, there are, if we talk about, let's talk about the roadmap. Okay, let's talk about the roadmap. Okay, a roadmap of DSA, roadmap of DSA. What all things we are going to learn in DSA? We will start from the basic data structures like stacks. We are going to talk about queues. We are going to talk about linked list. We are going to talk about trees. We are going to talk about graphs. These are the topics that we are going to cover, and so on, etc., etc. We are going to do particular things. If we talk about stacks, in stacks we will see about the inbuilt version or the STL version. Then we will talk about the custom version or what you can implement on your own. Okay. Then we are going to talk about queues. Queues can be of two types: the normal regular queues or your priority queues. We are going to talk about that. In priority queues, we have the 4 implementations. For example, we can implement a priority queue using an array. We can implement a priority queue using a linked list. We can implement a priority queue using a tree, a binary search tree, or we can implement a priority queue using a heap. Here we will talk about heap data structure also. Okay. So we will understand about all those things. Before we complete our priority queues, normal queues will be covered, and then later on we will move on to linked list concept. We will understand how linked list works, how to solve a particular problem on linked list. Then we will talk about different kinds of linked lists and finish up the linked list concept. We're going to talk about trees. What are trees? Different types of trees. Binary search trees. Binary trees, we are going to talk about all of that. Then we are going to talk about graphs. In graphs, we are going to talk about weights, edges, nodes, types of graphs. There are 12 types of graphs that we are going to talk about. Then we are going to start with the graphs related operations and algorithms like cycle detection, Dijkstra's, Prim's, Kruskals, Khan's, topological sort, all of that. We will start solving LeetCode and Coding Ninja's questions as well in our channel in this live session, and this is your roadmap that we are going to follow. But before even we start this roadmap, I want to start with a little bit of STL today, where today I am only going to introduce you towards a first type of collection, and that is vectors. Vectors are very important because most of our job, most of our problems can be easily solved using vectors. We need to understand how vectors work, how things work in vectors. They make our lives much more easier in DSA. Let us talk about that. Okay. So let us start. Now I hope so that I have cleared all your doubts and there are no new messages, and yeah, we can start. Let us start, guys. Today's first concept is going to be on STL. So let us talk about that. STL, Standard Template Library. This is our first concept in data structures. Before we go ahead and do anything in terms of data structure, we need to understand this. This is the place where we will talk about three things. Those three things are your number one, we are going to talk about collections. You might have heard about collections in Java. We are going to talk about those things only, but in C++. Because our course is being done in C++, we have concept of STL. STL is Standard Template Library, and here we have some templates of some particular structures or collections which we can directly import and use for ourselves, which makes our life far much more easier to do, to solve any problem, and that is why we use STL, right? So here we are going to talk about that first. In collections, we are going to talk about vectors, we are going to talk about maps, we are going to talk about sets, we are going to talk about pairs, we are going to talk about lists, and etc. 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 These are the different types of collections that we get. What are collections? The structures which allow you to store the data in different styles. For example, today we are going to talk about vectors. In vectors, we are going to understand about what are vectors, how do we do in vectors, and what all things we can perform in vectors. We can talk about maps later on in our sessions. We can talk about sets, we can talk about pairs, lists, etc. etc. like this. I told you that STL contains three things. That is, collection is the first one, and in collections we are going to talk about these many things. The second thing that we do learn is going to be iterators. Iterators. What are iterators? You know about different looping statements, right? We have for loop, while loop, different types of looping statements. Well, we also call them as iterative statements. We use this word called as iteration. That means someone who travels into a particular looping statement in programming, that means that. This is the meaning of that iterator. Iterator is someone who travels in a particular collection using a for loop or a while loop or any type of loop. That is what you call as iterator. Where every other collection, they may or may not have their own iterators, but generally in STL we also just talk about iterators. So here in this case there is one single iterator also, or maybe we are going to talk about different collections iterators. Today in vectors I am going to talk about both of them in one by one style. We are going to talk about that later on. So iterators, and third one is your inbuilt data structures. Inbuilt data structures. What I told you just now about stacks, queues, linked list, all of these data structures are by default available into our system in our C++. For example, here we are going to talk about the default data structure stack. We are going to talk about queues. We are going to talk about priority queues. We are going to talk about linked list. We are going to talk about linked list, and etc. We are going to talk about all of these concepts in this STL. Well, I hope so. Now that you have understood about STL, let us start with the concept here. So basically STL, again if I just summarize this, it is a standard template library, and this standard template library contains all these things: collections, iterators, inbuilt data structures, and in this part, let us start with our first data structure that we are going to talk about, and that is vectors data structures. Let us understand and start with this, guys, without any further ado. But I hope so that you have understood this very well. What is DSA, what is algorithms, what are data structures. I have given you a real life example. I have told you what is STL. Remember, STL is not available in C or any other language. This is just a quite simple feature of C++. One more thing I did not tell you about in this live session, why only we are doing it in C++, because in competitive programming in these days, in this modern worlds, we are going to use C++ in order to solve a DSA problem, and that's why C++ in this DSA live session. I hope so that this is very much clear and you have understood this really well. So let us start with our first concept in DSA, and that is vectors in STL. Because before we even go, we are not directly going towards data structures here. I told you we are going to just do today, we are just going to prepare for the first thing, and that is your vectors in STL. Let us start from there. So let us talk about what exactly is vector. Vector. You have understood and you have learnt about arrays, right? What is an array? What is an array? Array looks somewhat like this, correct? Array somewhat looks like this, right? What is the problem? You see, array have indexes like this, where you can store some data into it, here data like this, right? Now you have a particular, you have some pros and cons of arrays, because array is very nice data structure. First of all, the array uses the concept of storing the homogeneous data in one place, right? I can store multiple data but of same kind in arrays. That is the feature of array, right? But there are some problems in arrays. Problem is the size. Size is fixed in arrays. You want to do any operations on arrays, first of all, the size is fixed. Size is fixed, so you can only adjust some few elements into it. If you are gonna insert, let's talk about inserting an element in between, you need to shift all the already pre-existing elements into this, but then what will happen? You need to write the shift logic for that. And when you write the shift logic, what happens is this element gets deleted, right? So many limitations are there of arrays. That is why now we will use vectors. What are vectors? Vectors are also arrays, but those are dynamic arrays. Dynamic arrays. Vectors are dynamic arrays. What do you understand by the word dynamic? Dynamic means something which automatically changes according to the requirement. So in this case, arrays, but of dynamic size, of dynamic properties. That is what a vector is. Vector is ultimately an array only, but it contains all the dynamic properties of a particular collection. So basically what happens is that the size is dynamic in vectors, right? So for that reason we use arrays, vectors. They are very much helpful. They have so many features that you can use vectors for lot of reasons. For anything, they don't have fixed size, they have a lot of insertion and in lot of functions which makes our lives much more easier. For example, you can easily access the element, you can easily insert an element, you can easily delete an element. You have a lot of features that already comes with arrays. In today's concept, let us talk about both 1D and 2D arrays. Okay, so let us start with this and understand how this works. If we are talking about the syntax of array, of vector, first thing first is, because it is STL, it's a template library, What do you do here first is you first include the vector. So start by writing hash include, and in this write vector, because vector is a standard template library collection function. You need to include that and then start using it in your program. So I start by hash include vectors, and once I start with this, I can just say wherever I want that vector, I can just say vector, and then in the bracket, arrow bracket, I give the data type. I will give the data type. After giving the data type, here I will give the name of the vector. How do you create a normal array? You say ARR, the name of the ARR, you give the data type, and then you give this square brackets where you give the size. Here you have to mention the size. This is the problem with an array, but here you don't have to mention the size. If you want, you can give the size, but you don't have to mention the size manually. That is the property of an array, vector basically, a dynamic array in this case. So here you see we have vector of data type and then name. Now you have a vector called as name in this case. This is just the name of the vector. You can say anything, V I said. Now we will store that particular type of data type which you write here. Say suppose if it is of type integer, it will hold all integers value. If it is of type float, it will hold all float values. If it is of type string, it will hold all the string values. If it is of type bool, it will hold all boolean values. Well, I hope so that you are getting my point, right? So if I want to create a vector of type integer, I would say vector of type int, and then I give the name nums. And you have already created a vector called as nums, which can hold all the integer values, all the integer type of data. I hope so that it is very much clear. Now this is a normal array, not normal array, but a dynamic array, which you can use for storing or doing any operations into, like a normal array. There are a lot of features into the array, these vectors, which can make them much more easier and very much important for us to use. For example, let me talk about that later on though, but let us talk about all the things which are left here. This is your normal declaration of a vector. That is fine, that is normal. Then I said, if I want, I can also give the size of the vector if I want. If I don't have to though, because it is a dynamic array and it will automatically take care of the size in this case. But if you want, you can give the size also, which will make it fixed. So I can say vector of type int, and I said nums. If I want to give the size, I will give the size in this bracket, and whatever size I give, I said 20. Now the size of this vector is 20. I can hold 20 elements into this vector easily. Are you getting my point? I hope so that you are able to understand what I am trying to say. Correct? So this is your size given to this vector. Okay. What if I want to give a default value to this vector? That means I said create 10 size of vector and fill all the 10 values to maybe 0 or maybe 10, something like that. In that case, I will say vector of type int, and I say nums, and I say the size, this is the size, and I'll say comma, and I'll say the value 0. This will be your default value. This will be your default value. Now you can ask one question here, sir, you told that after giving the size you can give the default value, but can I give a default value without giving a size? Well, I don't think so that you can do it, because if you want to give a default value, you should be knowing the size. I said there are 10 members, and in the 10 members of the vector, you need all the 10 members to be initialized to 0. Then you should know what is the size, and that is the reason this syntax follows for that. Well, I hope so that it is very much clear to all of you guys, right? So basically this is the default value, this is the size, and this is how you declare and use vectors basically in a nutshell. Vectors are dynamic arrays, and you can give the size or you don't have to give the size, it's okay, that is fine. But if you know the size, better to give the size so that it allocates that much of memory only for the elements. But if you don't know the size, of course it will be dynamic and it can be automatically taken care of. That is what your vector is. We have learned just now that if you want to give the size, you can give the size like this in the brackets, and if you have a default value also, you can give the default value also along with the size of that vector, and this will help you a lot if you are doing a particular thing. I'm going to execute this and show you how it works. But as of now, I hope so that you are getting my point, what I'm trying to do. Okay, next thing is, okay, I have created the vector, but how will I give the data inside it? This is where we will learn about the functions of vectors. So vector has many different functions. A vector will have many different functions. Many different functions. What are those functions? Those functions are your identifier functions. Basically, you cannot say identifier though, you can just say something like iterators, iterator function say. This is the first type that you will learn. Then you will say capacity functions, you will say. Then you will say element access function. Then you will say vector modifier functions. Vectors, modifiers, functions, guys. Okay. So these are the things. So here these are the 4 functions that we are generally talking about. So basically here let us talk about them. Let's say I want to input a particular, we have a vector called as, let's say I have created a vector, say vector of type int, and I said the vector name is v. Now you are asking, sir, how we can put an element into this vector v? I can say v dot a modifier function called as push underscore back, push back, and you give the value right here, let's say 10. What will happen is now this 10 will go into this vector directly on the 0th index. In vectors also, the indexes starts from 0. Vector also follows 0 based indexing like a normal array. The only difference is that it gives you more features, like these are the features which we are going to talk now, and also it has a dynamic size. If you want, you can set the size. We have already talked about this. I hope so that you understood this really well, right? So let us, I have talked enough about these vectors. Let's go towards the programs and understand how we can do that. Let us talk about that. So let us shift towards our computer and understand how we can write the code. And there you go, we are gonna get the concept right here. So let us talk about this. So we have our this going on. Okay, so I have just wrote the basic code here, and let us understand about how we can do the job of understanding and creating the vectors. Okay, So first thing first, before I go ahead into any of these things, I'll say hash include, I'll say vector. Okay, vector. And once you say vector, now this vector is included into your program. Just a minute, guys. Something's gonna go wrong in this case. Okay, let me just duplicate the screen. Yep. Okay. So yeah, here we are. So we started by implementing our vector in this case. You see, I told you first of all, because it is a standard template library, we are going to include the vector, and this is what we have included in this case. Once you are included this vector, what we are going to do is we are going to create the vector. How do we create a vector? What was the syntax? We say vector, and we say the data type, and then we say the name of the vector, say v. I have created a vector called as v in this case. Well, I hope so that you have understood this really well, guys, that this is how you create, this is the data type and this is the vector. Right now the size is dynamic for this vector, but if you want, you can give the size also manually. How? By saying this bracket and giving that size right there. I said 10 is the size of this vector, so the size is set to 10 for this vector. If you want to set a default value, you give a comma and then you give a default value. I said 0. Are you getting my point, guys? I hope so that you have understood this really well. After this, let us say I have a vector. I have a vector. So I have a vector here, and I said that I am going to put some elements into this. Let's not give any elements size here right now. Okay, let's say I am going to put some elements into this. Let's say I create a for loop for int I. You start from 1 and I say I is less than or equals to 5, and I will say I plus plus, and I'll say that I told you how to give the element into the vector. You use dot pushback modifier function in order to give the element. So you say v dot pushback. You see, this is the function that we use, v dot pushback, and once we give this pushback, I can just give the number. Because our data type is of type int, I have given that, and this will push that 10. Because now I have given 10, it will fill the vector 5 times, 5 numbers, 5 elements will be there, and all the numbers will be 10. Or let us say I fill it with I. Well, I is 1 and it is going till 5. So what happens is, now in the vector it is pushing 1, 2, 3, 4 and 5. So right now this is the element. We don't have to worry about the size, guys, because we already know that it's a dynamic array. I just created a for loop which runs from 1 to 5, and it inputs these 5 elements. That's all. In this case, vector is going to be automatically fixing or setting up the size. If you want, you can give the size right here. I have already shown you that. Okay. So now you ask a question, sir, why and how we just print or work with this vector? So let me just tell you. The very first thing that I told you, there are 4 things that we are going to talk about in vectors. The first thing is iterator. The second thing was capacity function. The third thing is we are going to talk about is element access. And the fourth thing is we are going to talk about modifiers. So here let us talk about that. First, let us talk about iterators. So vectors, as I told you, will have its own iterators. In the beginning already I have explained you what is an iterator. An iterator is a function which is used to iterate or traverse across a particular collection, and in this example we have a vector as a collection. You understand my point? So vectors also have their own iterators. The most popular iterators that we have is begin and end. So I'll just write a comment right here and I will say iterators in vectors. And the first iterator we're going to talk about, and the iterators are basically, we have begin, we have end, we have R begin, we have R end, we have C begin, we have C end, we have CR begin, we have CR end. These are the vector functions, vector iterators, which we are going to talk about in this example. Let us understand about them one by one. Okay, so here let us say I am basically, because I have just shown you about how we can just implement the array. Here in this case I have just pushed 5 elements into this, and now let's say I want to print. To print I can use an iterator like this. This is the place where we use iterators. To use the iterators, what I will do is I will say here a for loop, a nice small for loop, where I can say for I can say auto. For auto I is equals to, I say start from begin. But what begin? Or what is the name of our vector? V is the name of our vector. So I will just say I you start from v dot begin, and this is our iterator. I is the iterator function, right? I is the iterator function. So in this case, because I is the iterator function, I am saying that start I you start from the begin. Begin is the iterator. Begin is the iterator which will point towards the first element in the vector, and that is what begin is. So I say I you start from v dot begin, then I you go till less than or equals to the less than end. But what end? V dot end. V dot I is, oh sorry, we use semicolon. I is less than v dot, we say end. End is the iterator which will specify the last position or the ending element into the vector. And I said I plus plus. Now because it is an iterator, iterators will not hold the value, guys. Let me just tell you this very clearly. Iterators will not hold the value. Iterator will hold the address of the element where we are starting from and till where we are going. So in that case, it will be starting and ending address. That means here we need to use a pointer. So if I want to print the value, I would just dereference the I and L, not end L though, I am going to use space so that it prints the numbers easily. Again, why I am using a star I? You know pointers. What is star in that? Star is called as dereferencing operator. So I am dereferencing because I is now holding an iterator. Iterator will return an address. So in this case, it will store a address of the first value. This holds begin holds the address of the first element and end holds the address of the last element. And when we dereference that address, because you see I v dot begin will give a reference to the I, and I is that I. Now I is a reference. I is a storing a reference. That is why I have said auto here, because it will hold the address automatically. We don't have to give any data type when we use auto, because it will automatically take up that particular data type rather than we worrying about anything else. So we don't have to say always the pointer in this case. So I said v dot begin, it will hold the address, and when we dereference that address, that is why we written star of I, because I is a iterator in this case. So we need to dereference that and we will get the value. So now when I run this code, it should print the values 1, 2, 3, 4, 5. We have pushed I into the vector v, and what we have done, we have pushed started from 1, we went to 5, and then we have referenced it. So in this case we have got this vector in this case, guys. I hope so that this is very much clear to all of you. Correct? Let's move on. This is our iterator. Okay. We have pushed back 5 elements 1 to 5 and we have used an iterator in order to print this. Okay. We are going to talk about R begin, R end. When I am talking about R begin and R end, R here stands for reverse begin and reverse end. Now if it is reverse begin, that means the R begin will hold the last value from the reverse side begin, and if I say R end, it is from the reverse side end, that means the first element. Now it will print 5 4 3 2 1. Let us run it. 5 4 3 2 1. There you go. Well, I hope so that this is very much clear to all of you. Okay, this is R begin and R end. We have C begin and we have C end. Here C begin and C end means constant begin and constant end. It will also print the same thing only 1 2 3 4 5. We are just talking about constant values. These values will never change later. Okay. Then we are going to talk about CR begin and CR end. Constant reverse begin and constant reverse end. In this case also it will print 5 4 3 2 1, but they will be all constant, you cannot change them. And this is your all types of iterators. I hope so that this is very much clear to all of you. I am going to use only just the normal begin and normal end, and these are your iterators in vectors. Done, finish, over, done. This it was very much easy. Okay. I have pushed 5 elements till now and I have used an iterator here to print the elements. Let us talk about the next type of things in vectors, and that is capacity functions. What are capacity functions? What are capacity functions? Capacity functions are those functions which will show you what these functions are related to the capacity of the vectors. For example, the size, the maximum size, the capacity of elements that can be held into the vector, maybe resize, shrink to fit. These are the capacity functions. Let us talk about them. The first capacity function, let's talk about capacity functions. Capacity functions in vectors. So I'll start by printing the vector's size. So size of the vector is going to be v dot, the first capacity function is size. So I said v dot size in this case. So I have said cout size and v dot size. This v dot size will print the current number of elements into the vector. So there are 5 elements, so it should print 5. So I'll just say it should print now 5. So when I run this code, you see size is equals to 5. Well, I hope so that it is very much clear. I'll just put a cout and else statement here and else statement here, and this will be done. So now it prints in the next line and it prints like this, size is equals to 5. This is our first capacity function, guys. Now I said cout. I said the next thing what we are going to do here is the capacity. Capacity. There is a function called as capacity. So v dot capacity. Okay. V dot capacity. What is this v dot capacity? Capacity is a function which will actually print 8 in this case. So when I say capacity, it prints 8. You see, it prints 8. Let me just put an end L so that it is very much clear to all of you. You see, capacity is now printing 8. Why it is printing 8? So let us understand what is the capacity. Capacity is your every vector, I told you, as it is dynamic, right? Size is dynamic. So when the size is dynamic, what happens is that the elements stored into it, for them, the compiler will in advance will allocate some memory, and that allocated memory for the number of elements is the capacity in this case. So that when you input any number, in a vector, the memory is already allocated for some extra elements. So you don't have to allocate the memory while entering those numbers. In a nutshell, capacity will show you the future allocated memory in future actually, basically. The future allocated memory for the elements without you, while you are entering, when you enter a number, the vector will not allocate the memory because the memory is already allocated in past the memory is already allocated. So this 8 is the already allocated memory for this vector, so that while you are entering the element, your vector will not allocate the size manually again and again and again and again. This is future proofing in vector. Basically, this is just a memory which is already allocated before the time, so that when you enter an element, the vector will not allocate the memory manually for everyone. It pre-allocates the memory for those number of elements, and default it goes from 4, 8, 16, 32, 64, 128, 512 and so on. It keeps on going and rising and rising and rising like this. I hope so that this is very much clear to all of you. Then comes your C out. We have maximum size. So I say max size is gonna be V dot max size. What is this max size, guys? Max size is the theoretical limit of vector to store the numbers. It will print a very big number in this case. So you see that max size is equals to, it is printing this number. It's a very big number, right? So basically what it is doing is, I'll just print it in the next line, and L, and here also I'll just put and L. It will print a very big number in this case. This is the theoretical limit of this vector can store these many elements in this time, at this point of time. You will never actually store these many numbers, or you may not be able to store these many numbers in a vector at a time, or you will not be used because this is not of practical use. This is just a theoretical limit which is showing. Are you getting my point, guys? I hope so that this is very much clear. The next type of element that we are going to talk about, the next type of function is which we are going to talk about is C out, not C out. I'll just say the next capacity function is V dot. You can resize the, actually resize would be called in modifiers, but it's okay. I'm just calling it here. I can resize the vector. So I said resize into 3. And what happens if I just print the capacity and the size? This resize will resize the vector in, and it will delete the elements more than 3. So right now but it will not affect the capacity though. Capacity, the memory allocated will be 8 only, but it will reduce the size. The size will be 3 now. Let us see. Let us run the program and see. First the size was 5, then the capacity was 8, max size was this. Now the size is reduced to 3 because we have used the resize, and the size is now 3, but the capacity is still 8 in this case. I hope so that this is very much clear. Okay. That is the reason why we are going to use this resize. Then we have V dot shrink to fit. What this shrink to fit will do is that right now, before I do anything, let us just print the numbers. Let's just print the vectors. Before I go further into shrink to fit, I'll just show you what happens when you are doing this. So when I say print the elements, it is printing just 1, 2, 3. First it was 1, 2, 3, 4, 5. Now it is just printing 1, 2, 3. I hope so that this is very much clear to all of you guys. Then we have shrink to fit. This shrink to fit will not reduce the size of the elements. The elements will be 3 only, but the capacity will be shrunk to the size limit. In this case, there are 3 elements. The capacity will also be shrunk to 3. From 8 it will come to 3. So now if I print both of them, now in this case the size becomes, in this case 3, here also it was 3 only, but the capacity was 8. Now this will also become 3, and now you see when I run the program, you see size is 3, capacity become 3. First it was 8, and while this was the resize thing after resizing, and this is after shrinking to fit, shrink to fit, and these are your capacity functions. Easy, right? I hope so that this is very much clear, right? So basically these are the iterators which we have talked about till now, and these are the capacity functions which we have talked about. We are progressing good into the array vector. Let us talk about our element access function. So I said element access functions. Okay. So I said the first element access, these functions are basically used in vectors to access the elements based on their indexing and do some operations. So for example, we have the first function as v dot, basically not dot, I will just say a reference operator. Basically this is going to be like normal array. You write the name of the array, and in the brackets, in the square brackets, you give the index. So I'll print the 0th index. So see out, and what is there in the 0th index? 1 is there in the 0th index. So I send, give me that, and it printed 1. If I say give me the second index, on the second index what is there? 3 is there. So it will print now 3. I hope so that it is very much clear. This is your first element access technique. The second element access function is v dot at. When you say at, this will also work on the same principle. You just have to give the index. I said at 0, it will print again 1. First it will print 3 and then it will print 1. So 3 and then 1. I have not given end L, so that's why it is looking like 31, but it is 3 and then 1. So I'll just use this. First 3 and then 1. I hope so that this is very much clear to all of you. These are the two functions. First this is just the operator here. The second function is the at. Next element access is, if you want to access the first element, then you will use what? V dot front. And this will give you the frontmost element, which is 1 in this case. If you say see out, give me v dot back, it will give you the last element in this case. So now it will print 3, 1 and then 1 and 3. This 3 is coming from the reference operator, this is from at, and this is front, and this is back. I hope so that this is very much clear, right? And these are all your element access functions. Okay, these are your element access function. Last type of functions which we are going to talk about is the vector modifier functions. Vector modifier functions. So basically what is this? These are the functions which are used to modify the vector. For example, pushback. In the beginning I have used pushback, right? This is a vector modifier function which allows you to work with that. Let us cover that. Okay, I said I want to push back the elements. I said v dot pushback. We right now we entered 5 elements, then we resized it, so 1 2 3 was there. So I said 1 2 3 is right now in our vector v. Now I said push back 100. Push back means push this 100 at the back of the vector. Back was 3, so after 3 this 100 will be pushed back. And if you want, I can show you by just printing that as well. So I'll just copy and paste this iterator for loop so that it prints the elements which are present into that vector. So I'll say print it now, and it will be 1 2 3 and 100. 1 2 3 and 100. I hope so that you are getting my point, right? So this is how it is done. Okay, now let's say v dot, if you think, sir, is there any push front? So let us see, there is no push front. Push back, it works on the simple array concepts, so there is no push front. This is not a linked list, guys, this is a collection in STL, which is just a dynamic array thing. I hope so that you are getting my point. So in this case, we have just pushed back. I said, okay, I am pushing back 200 more. There you go. Now I will just print it. It will print 1, 2, 300 and 200. Did you get my point, guys? This is your first vector modifier pushback. Let us say, now I am saying v dot, the second modifier is pop back. Pop back means delete from the last element. Pop or means delete, back means the last element. Last element was 200, now that last element is popped back. So I'll just write it here. I'll say v dot pop back and then use print the elements. So I send, I was not declared in the scope, wait a minute, and now you see. See, first 200 was pushed back, now it is deleted. This is called as pop back. Are you getting my point, guys? It's very simple. Let's say you want to insert a number in the front or the back. I can say here v dot insert, and insert will take two parameters. First one, where you want to insert. The second thing, what is the value what you want to insert. The first parameter will be the iterator, in this case iterator. So here we are having v dot, the iterator is, let's say, begin. On the beginning, push 200. Okay. V dot insert, at the beginning push 200. So v dot begin comma 200, and then I am saying print it. So now you see 200, 1, 2, 3 and 100. Did you get my point, guys, everyone? Very easy thing to understand. Okay. Next, if I want to insert anything at the last, I can say v dot insert. This time give the iterator as the end. So I can say v dot end, comma, I want to push 500 at the back. I said okay, print it and see what happens, and there you go, 500. Are you getting my point, guys? I hope so that you are able to follow the code which I am writing here. Next thing I said, sir, you have told that how to push the elements in the front and the back or insertion, but how I can do it in the middle of the array, middle of the vector. This is where you will learn about the second thing in STL, and that is your iterator. I told you the iterators, the default iterators of vector, begin, end and all of that, we know this. But let's say I want to create my own iterator. I will create my own custom iterator which will run on this vector, and it will hold that position. The idea is very simple. First write the definition of vector. So vector of type int. In this type of vector, I will say scope resolution operator. In this scope of vector of type int, because our v is also a vector of type int, right? Our v is also vector of type int v. So I can say that on this v I need to do that, right? So I said v of vector of type int, create a iterator. You have to say iterator, and then you will give the name of the iterator, itr. This is the name, itr. And what will happen is, now this iterator is capable of iterating on this vector, but I need to also hold the value. So I will say equals to, and I will say from the v dot begin, from the beginning plus the particular position that you want to go. Say for example on third index I want to go, so I said plus 3. And this itr will store the third index. Now you can use this itr in that v dot insert and pass this itr, and this will be the third position, and 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 it will, let's say I want to insert 600 on the third index. There you go. Okay, I have not printed it. Let me just print it quickly. So you see that 600 is pushed into the third position. One second, guys. One minute, guys. Technical difficulties. Yeah, we are back. Okay, guys. So we are back. Actually, some technical difficulty happens. Our camera stopped working. Now we are back into the stream. Let's continue. So here, I said using this iterator, where I have put the third position, I have saved third position into this ITR, use that ITR and at that index push 600 and then print it. So you see 0, 1, 2 and third index is this, and 600 got inserted at that particular index. I hope so that this is very much clear to all of you. I hope so that you are enjoying this video. If you are enjoying this video, please give us a thumbs up and do not forget to like, share and subscribe to our channel. Also, share with your friends who are learning DSA so that they can also understand how vectors work. Let's continue. So you see, I am using ITR. I have used ITR 600. I have put 600. Basically, ITR is the iterator which is storing this position 3. If I change this position to 2, this will change the position and the insertion will happen now at 2, 0, 1 and 2, 0 based indexing, right? Correct. We understood this, sir. Now, okay, we have got 2-3 things. We have v dot in place, So I said in place. In place also will have some iterator. In place means insert only. So either you use insert or you use in place. It is the same thing. So I said in place at ITR, that means at the second index, because ITR was holding the second index. I said ITR at that second index, push 700 now. So I said okay. Print it and you see on the second position again. 1 minute, something happened. Is it not taking it or something wrong happened? Okay, 1 minute. Till here it is working fine. If I use this, v dot in place, it will take a iterator position and then it will take the argument. So I said that in v dot begin, push 700, okay, and then printed. Yeah, so you see that 700 in the beginning, I don't know, I did not know what happened, like guys, in between something happened, but now we are on the back. We are back and in the position. You see, v dot begin is the beginning position and we pushed 700. This is what in place does. Basically, in place does the same exact job as insert. Okay, so you don't have to worry much about it. If I say here v dot in place, let's make changes here. Rather than this, let me just pass ITR, and it is not working properly there. Basically on the second index it is not working properly, maybe because it is already putting at that particular position, maybe. Okay, but this iterator is working fine. Okay, we will see that later on. I said v dot emplace back also we have. V dot emplace back means just you have to give the value, let's say 800 I want to emplace. Now you see what happens is that this will emplace 800 at the back. This is emplace back, like push back we have emplace back, insert at the back basically. Okay, I hope so that this is very much clear. It is easy, nothing is there in this. Well, okay, let us understand this. Anything else left? Yes, we have v dot erase function, and I said let's erase 200. What happens if I say here erase 200? You know, this is not taking it because this is just taking the value. If I say erase v dot begin, then it will erase the element in the beginning. Right now I have not printed it though, so now it is printing it. You see, the first element got erased. It is also taking the iterator. I said here v dot, you say erase itr, which means it will now erase the second index. I hope so that this is very much clear to all of you. Okay, one more last thing which I want to tell you about one dimensional array is v dot clear. When I say v dot clear and then I print it, see, it is cleared. Clear means empty, delete all the elements in the vector. But when I say erase, erase will delete only a particular element into that vector. I hope so that this is very much clear. We are going slowly and we are going nicely into the video. I hope so that we are able to understand this. If you have any doubts, you can please ask in the comment section. Also, yeah, I did not see the comments, but yeah, some people are still commenting. I hope so that your doubts are clear. Shri Hari Murli, right? I hope so that your doubts are getting cleared, guys. This is your one dimensional vector. These elements, these things, these functions are enough for us to understand about vectors. This is one dimensional vector, and with this much of knowledge you can start progressing and understanding the questions and problems into your regular places. You can use lead code, you can start working on lead code problems, you can start working on coding ninjas problems, and you can start with DSA problems. But this is just the start, this is just the beginning. In today's class we have just learned about one dimensional vectors. Quickly I will give you something in homework, guys. You have to tell me in the next session. Before I come, I will start by I'll just tell you right now only. I'll just directly tell you about two-dimensional vector here. Basically, just a small thing I'm gonna do, or let's do one thing. Start with this. Let's just start with this. This was your one-dimensional vector. This was your one-dimensional vector. If I want to create a two-dimensional vector, what can I do? Can anybody tell me in the comment section quickly? How can I create a two-dimensional vector in this case? Two-dimensional vector, let me just tell. Now, if I want to create a 2D vector, how will I do that? I can do it like vector of type, what I will say? Vector of type, another vector, vector of type, vector whose type is int. That means what I did? I said vector inside a vector. Okay, vector inside a vector. This is called as two-dimensional vector. Did you get my point, guys? I hope so that this is very much clear. Vector of type vector, and then you give the name. This is a two-dimensional vector, TDV, two-dimensional vector. Okay, like this, and you don't have to worry about anything. Okay guys, I hope so that this is very much clear. Alright, so vector of type vector int, I said in this vector there will be another vector. Okay, both the vectors are dynamic in size right now. We don't have to worry about their sizes. So their sizes will be still dynamic. Okay, but what if, sir, I want to declare the size. I want a vector of type x by x, something, n by n size I want. Sir, I want 1 by 2, or sir, I want 2 by 1, whatever type of vector. How can I do that? Let us see that. I can say TDV is a two-dimensional vector dot resize, and I said resize the outer vector. This is for the outer vector. I said the outer vector will be resized to 10, and for the inner vector I want to give a comma, and I said resize the inner vector, which is vector of type int, resize this to 10 as well, and there you go. This will create a 10 by 10 vector. Understood my point? The concept goes very simple. I created a two-dimensional vector of type vector int, and I said resize that to 10. This is going to be the value for the outer vector. 10 is going to be for the outer vector. Remember this, guys. 10 is the size for the outer vector. And if I want to give the size of this inner vector, I need to give that vector of type int right here. Okay, vector of type int right here, and then give its a size like 10. So this is 10 for this outer vector, and this 10 is for the inner vector. That is why I have repeated this here. If you see this carefully, guys, okay, you see this and this is exactly the same. This and this is exactly the same. So vector and inside vector also size is 10. How do I print it? You know how to print, right? For, I will say auto, or let's say I say int I is equals to, you know the size, so start from 0, and I said I is going to be less than 10, and I said I plus plus. Inside this, you know how to print a two-dimensional vector, right? By creating a nested for loop. I said for int j is equals to, you also start from 0, j you go till less than 10, and j plus plus. Correct? And now inside this, I said print TDV. So C out of TDV of I and j, and print some space. And once you print that, after the first for loop, say C out and L. Guys, you know how to print a two-dimensional vector? This is how you print it. But when I run this right now, nothing gets printed because there is nothing in that. In that 10 by 10, we have not written anything. But what if I can say the default value of the inner vector? I told you in the beginning, guys, if you remember, if I want to put the default value, I can just say the size 10, comma, the default value. Correct? So why can't I do that same thing in the inner vector for the two-dimensional vector? I said resize 10, the outer vector, and the inner vector with 10, comma, give a default value. Default value is given to the size, right? So I said comma, default value is 0. When the default value is 0, now let's create a 10 by 10 vector where all the values are put to 0. see for yourself in this case. So right now when it is not working, it is not working. Why it is not working? Because I am not printing that very well. Something is wrong. It should print that. Is it not printing? Maybe because I have fixed the size, or maybe I should use a element. Something is wrong. If I use auto, if I say here auto, I said v dot begin, and I said, then in that case I need to give this, and I said v dot end. If I use an iterator, in this case I would also do the same thing, correct? I'll just copy this and I will just paste it here. This will be j, and this will also be j, and then this will be star j. This should work. Maybe because I have taken the size very big. Let us take the size as 5. Let us take the size as 5, and it is not working, guys. 1 minute, guys. Let me just check this out. 1 minute. 1 minute. There is something wrong. What if I don't use the vector? I will do one thing. Let us do this. Say for example, let's not do the resize thing, but let us do it directly here. I said I will directly give the size, and I said in the vector of type int, resize this with 10 and give the default value as 0. And because it is not working, why it is not working? Because I haven't given this as 10, and this is 10, this is 0, this will be 0, and this will be 10. J and I, it's not as much. And guys, 1 minute. Here maybe because I have not taken it quite well. Okay, let me do this. Okay, let's remove this part, and see, let us say I have defined now 50. Okay, maybe I will create another file here. Let me just create another file here. Because I am saying clear, it is not working directly in this, let us say, this will be in the main. Okay, let me just create another file here quickly, iostream, and I'll say using namespace std, and I said in the int main I said like this, and say hash include vector. Okay, I have created a vector and everything works fine. Why it is not taking? Vector is undefined. How is it possible? I have to say this again. Vector of type int tdv, and here I said resize it to 10, comma vector of type int size is 10, comma initialize them to 50, and run this. Yes guys, it's not the program's fault, actually it was the fault with this file, I believe so. Maybe because I've used the clear command, maybe it is making that thing clear of something, but it should not happen. See, the same thing I've written here, but in the output it was not showing. Yeah, now it is showing actually. Now it is showing. Yeah. So guys, you see, I've done one thing here. I've created a two-dimensional vector of type vector. Sir, is it because you are just initializing the inner vector? No, initializing the inner vector will also initialize the outer vector. See, it is working now. The thing is, there was some issue with my maybe the terminal window or something, but yeah, the code is correct. Because you see, we know this whenever we initialize the inner vector automatically, because the type of the outer vector is the inner vector, right? The type itself for the outer vector is inner vector. You see, vector of type vector int. So if the inner vector is of type int, the whole vector is of the type that vector. In this case, if you initialize the inner vector, automatically it initializes the outer vector also. So there might be issue with my terminal window because everything is correct only. It is fine. You see, TDV, we have created the two-dimensional vector here. We have initialized the size of that outer vector to 10, and then I set the same vector here, and then I said 10, comma, I have initialized it to 50. If I initialize this to 0, this will work here. Like this also, you see, 10 by 10 vector of initialized value 0. Looks good, looks fine, right? Now if you use, even if you use the resize, it should work. So let us just try that. tdv.resize, tdv.resize, and I'll just copy the whole thing right here, and I delete this. This should also work basically. It should be the same because now I'm just using resize. Yeah, see, working fine. Because just now we have understood this, right? That resize will also do the same job. But in this case, I was doing that in the one line, but now I'm just saying dot resize. Well, I hope so that you have understood this really well. So this is tdv.resize, and then I have resized the same thing. So the inner vector, outer vector, no confusion. Everything is same here. Looks good. We are just using the OG, original way of printing the two-dimensional vector in this case, and I hope so that this much is enough for you to understand and work with vectors and start with DSA. I want you guys to give it a try to solve some problems on vectors on online and see what problems you get. You have any problems, you please ping me on our YouTube channel in this live section, comment section below. Later on, this live session will be live, published into our YouTube channel for the offline viewers, of the viewers or the regular subscribers here. So if you haven't watched this live session, I definitely will be posting this live session into our channel. If you have any doubts, please tell us in the comment section below, and in the next week's live session on DSA, I will solve those doubts directly in front of you. And I believe so that today it is enough for me to tell you about this vector. I hope so that you have understood this really well. Okay, so this is what we are going to discuss in today's class. That is enough for today's class. There is no proper duration of these classes as of now, because we just started with the DSA concept. Depending upon the topics, I will cover the topics. How long that topic is, I will divide the live session into different styles and different durations. We will talk about that soon. Next week, before coming to the live session, I will be posting all my links and everything for the DSA live session on our social media platform for Coders Arcade, where we have in LinkedIn, Instagram, Twitter, everything, everywhere I will post this link to our DSA placement series live session every week. Generally, the timing will be every Saturdays, but if you feel like the frequency has to be reduced down, or the speed of the technical sessions have to be moved a little bit up or down, you please tell us in the comment section below. We will try to cooperate with you guys, and I will keep on creating more and more good things. Also, not only just the placement series DSA, but I will be posting sessions on machine learning as well. Soon we are planning to start machine learning sessions on VTU syllabus, the VTU syllabus that we have got from different colleges. Basically the latest scheme, we are following the VTU, we will follow the the VTU syllabus, and we will start working on different modules, module 1, module 2, module 3, module 4, module 5 on machine learning. We are going to start with that, and I am also probably will come online live session with machine learning sessions also. Next week, let us see what is our plan. Based on that, I will be working on these live sessions. Next Saturday, probably after this, the next Saturday it will be there. So when will be the next session? Next session will be for the DSA. The continuation of this live session will be on the next Saturday as of for now. But any changes or anything announcements, I will be definitely posting it into our YouTube community and also our channel's social media platforms. So don't forget to stay tuned and follow us on Instagram also, on Facebook, Instagram, on Twitter, LinkedIn, and on WhatsApp. In WhatsApp, we have created a community called as Coders Arcade. So please also join there as well. If you want, I can update the codes and the notes. I'll post my notes and codes on DSA placement series there. And yeah, I hope so that you are able to understand today's session. Well, thank you so much guys for being with me in this session. If you have any doubts, please ask me in the comment section below. Well, I hope so that your doubt is also clear. Shri Hari Murli, I hope so that I have cleared your doubt as well. Yes, in the live session, as I am seeing the chat. Yeah, thank you so much. I hope so that you have understood today's session very well. Please share this live session with your friends and those people who are learning DSA, and let's keep on learning. This is Ashank David. Thanks for watching. I'll be closing off this live session now, and I'll see you very soon in my next video. My next video, on regular video on our YouTube channel, will be on machine learning next. So stay tuned for that, and most probably that video will come on Monday, the next week's Monday, first day of the week. So stay tuned for that. If you want to learn machine learning as well, I'll start posting the videos on machine learning also. Most probably the continuation of this DSA session will be on the next week's Saturday. Timings I will post. Generally the timings, it will be on 6 PM. Today it was a little bit late, but that is fine. I'll try to come a little bit early also in Saturdays whenever it is possible. Thank you for watching guys. This is Ashank David. Thanks for watching. I'll see you guys in the next one. So yep, we will cut this off.